All right, so for part C, we were asked to determine the concavity of the curve at the points on the interval from negative pi over 2 to pi over 2 and give a reason. So many of you knew if we're asked a question about the concavity that right away we should be trying to take the second derivative of the function. So let's write down what the first derivative was again. So this problem's another great review of implicit differentiation, but also using the quotient rule, which hasn't come up quite a bit since we've been looking at these practice FRQs. So the second derivative is the bottom function multiplied by the derivative of the top function, so the derivative of 2 is 0, minus the top function multiplied by the derivative of the bottom function. So the derivative of 2 again is 0. Here, the derivative of negative sine is negative cosine, derivative of the outside with respect to the inside, times the derivative of what's inside. We're still doing implicit differentiation, all over the bottom squared. There were 2 points available for this second derivative, so anybody that got this far, I at least gave them 1 point. Then the second point came from remembering to substitute this derivative back in here. So let's clean this up a bit. Here, this is multiplied by 0, so it goes away. Negative times a negative will be positive. And then I have 2 over 2 minus sine of y, all over 2 minus sine of y squared. So I'm going to go ahead and take this denominator. This is a complex fraction. This can go within the denominator that's here as well to clean it up. So now we've got 2 minus sine of y cubed. Okay, and then we have here 2 times the cosine y of 2. So that is 4 cosine y. Okay, and here we have this interval, right? So what I need to think about is on that interval, from negative pi over 2, which is down here, to pi over 2, if I'm on the unit circle, if I think about the sine and cosine values that I could possibly have, would this whole function be positive or negative on that interval? So we do have some negative sine values. First of all, cosine's always positive, right? Because it's the x value. So in these two quadrants, the x's are always positive, so this cosine y value will always be a positive number. So the numerator is always positive. So we just need to decide, well, is the denominator always positive? In this case, it will be, because I have 2 minus, here, even if I plug in the negative 1, when I cube that, I get something positive. If I plug up here 2 minus a positive 1, the values here are going to range between 3 and 1, and then I cube them, I'm still going to get something positive. So the numerator will always be positive, analyzed on this interval. The denominator will always be positive. So to earn the third and final point on this rubric, we had to say the derivative is always positive on the interval. Interval. So the function is concave up. That was only 1 point for that last analysis piece, so you really earned most of the points here for showing all the second derivative work, and a lot of you guys started correct work here. Not everybody got to this simplified version, but I even gave full credit here. Anybody that left it in dy dx term, though, I couldn't give you the full 2 points. So remember that you have the dy dx to substitute it back in, and we practiced that before together in class.